Greetings, everyone. Today, my team and I are excited to present our project, Food Assistant Chatbot. Before we dive into details, let's take a step back and look at some facts. Did you know that globally, 1 in 5 deaths, which is over 11 million people every year, are linked to poor diets? In Asia, rising obesity and stunted growth in children under 5 are major concerns, both based by unhealthy eating habits. We all go through different phases in life, and as college students, many of us struggle with time pressure, stress, and limited nutrition knowledge, which often leads to poor meal choices, which will also cause long-term health issues. Another massive issue is food wastage. Around one-third of all food produced is lost or wasted, amounting to nearly $940 billion, which is a staggering amount of numbers. That's not just a waste of money, it contributes to nearly 10% of global greenhouse gas emissions. If there's one small thing we can do to give back to this planet, it's to be more responsible with our food waste. Then there's the issue of allergens and dietary restrictions. Most food platforms or recipe sites don't clearly flag allergens, and many people don't bother with the extra hustle. So they just end up eating the same meals again and again. As someone who's quite indecisive, I find the process of choosing what to eat 2 or 3 times a day absolutely exhausting. And honestly, don't you feel the same sometimes? Aren't you tired of Googling recipes, scanning through labels, and still ending up unsure of what to eat? What if you could just tell an app what you are craving, list a few leftovers you have, and instantly get the perfect meal idea, which is customized for your diet, health goals, and allergies? Well, this isn't a far-off futuristic dream. That's exactly the promise of our solution, Food Assistance Chatbot, your smart food companion that helps you eat better, waste less, and stay safe effortlessly. Our chatbot calculates calories with a breakdown of each ingredient. It will recommend meals based on your preferences and dietary needs, which will also include allergen and diet filters, and even transfer your leftovers into something delicious. It works with both text and images. With this, we aim to make eating not just healthier, but also easier and more sustainable. These are the models that we have used in our system, and we have also used multimodal, which is Lava, and you will hear more about it in the code.
Let's take a look at the workflow of our application. So as you can see, we try to implement how RAC works. So we receive the text and image, like asking the recipe of this food in this image, and our application will work and provide the response accordingly. But there are a lot of steps going on in this part. But let's take a look at the first step, the zero-shot classification. In this function here, our model could perform a zero-shot classification, which could classify the tasks into 3 different tasks: the cook helper, which to help provide the recipe, the calories calculator, and the meal planner to recommend the recipe based on the remaining ingredients in the picture or from the text. And after we classify the tasks, this could be an additional information when we are doing the prompt augmentation. And this is the demonstration. As you can see, when users say give me a diet plan, it could be classified as a diet meal planner. Next, we're going to extract the constraint from the input text. And in this part, we have constraint keywords like but, without, except, etc. And what we are trying to do, we're trying to iterate through every text in the input, and we strip those part of information which is located with these constraint keywords and add it into a list of constraint. And for this constraint, it's going to be used as a part of how we're filtering the result from similarity search. And as you can see, when user asks, give me the recipe of this burger without cheese, it could identify the constraint right away. Now the next part, we are going to do an embedding. We're going to embed the image and text from both input and from the database. So let's take a look at the pre-process of the database first. In this part, we are trying to get a metadata dictionary list, a list of dictionary. So basically, our database contains different types of food, which each food will have a property like the ingredients, the recipe, a total calories, etc. But all of these are going to be included into a single dictionary for each row of food, and it will be contained later into a list of dictionary. And this is the example of the output. Now the next part, from the dictionary that we have created, we are going to combine all of those keys and values together into a single string so that this string could be used for an embedding step. Also, we have to do the metadata dictionary list for the image dataset as well, which will include a name and the part for image for the later process. Now, in this embedding step here, as you can see, we have two different models. The clip model, which will handle the data type of image, and the sentence transformer, the sentence model, will handle for the text data type, the string. So after we embedded the text, as you can see from the rich text that we have done in the previous part, we would get a list of vector, as well as how we embedded the image into a vector. So we get a vector database for dataset image and text. Now we receive the input and then we embed it into a vector. But why do we have two different models? So the sentence model, it will handle perfectly. I mean, it will be preferable if we use for only question types in the case when user input only text. But for the case when user input an image and text, both of them, it will be better to use the clip model in this case to perform a better similarity search. Now, moving on to the part where we do similarity search using the FICE library. So FICE library will try to create an index from the vector database, and we could identify the type of index, like we identify in this case an L2, a Euclidean distance, when doing the similarity search, which FICE will help us facilitate and calculate the similarity search efficiently. Which you can see that in the part where we do the search, it could get the result as a distance from the L2 search and the index accordingly. And you will see the result iterated as this part where we get the distance, and from the index we can retrieve the rich text from that as this output.
Now, I'll be talking about the filter content containing constraint list. The first code uses the FICE to search for similar text based on the query. It keeps repeating the search if too many results are discarded due to not meeting the certain rules. Each time it increases how many results it checks, so this way it makes sure that there are enough relevant results, and the FICE help us to find similar data quickly. And for the second code, it processes search result by checking each food item details. It filters out items that contain allergens or unwanted ingredients based on the user constraint. If the result is too different, it stops early. So the goal is to collect only safe and relevant food options. Now we're talking about the re-rank using cross-encoder using rec. Here, the code reorders a list of text results based on how well they match the user query. It uses a re-ranking model to give each piece of a text relevant score, then sort them from most to least relevant. So this help ensures that the most useful or accurate information appears first in the final output. Now, the system has to be prompted back to the user regarding retrieval information. This code builds a tailored prompt for the AI based on what the user wants, like planning meals, calculating calories, or getting cooking help. It combines the user query related text and the optional image to form a clear instruction. Depending on the text, the AI is guided to respond in a specific way, such as giving nutritional information or recipe steps. Now, finally, our AI responds back to the user. These functions generate the AI response based on the user's conversation and its input images. They prepare the input using the chat template and process it with the language model. The function streams the response as it's being generated, which is useful for the real-time interaction. And also, it responds clearly and accurately based on the user input. These are the test results of our full RAG and the LLM model. This is a demo video of our application. Now I'll be talking about the quality and accuracy of our application. First, it's a domain-specific dataset using the food recipe, food allergy, allergens, and the nutrition dataset. It also accepts the input prompt and the food images to create the response, using the segmentation model to isolate individual food items, improving recognition and portion estimation accuracy. And we also have enhanced RAG system. Before releasing to the public, we will be having the beta testing. This is a comparison chart of our application compared to our competitors' app. Most of them, they don't have AI integration, they don't have recipe generation or allergy aware substitution, and a specific meal plans. For our app, we will be having AI integration using Lava and REST cross check around more than 100 allergy database. We'll be having real-time ingredient swap and the suggestion of recipe generation as well. This is our revenue model projected to create in 1 year interval. We'll be offering the freemium model and the premium model, which is around 300 baht a month. The freemium model consists of the ads, which is the revenue got from the external sources, and the premium model will be the users and our customers, allowing them to use unlimited queries, meal planning, and the API access. So from the premium subscriber, we expected that we'll be having around 1,000 users, which will generate around 4 million baht a month, and we'll be having the freemium ads revenue, which will generate 2 million baht. Total is gonna be 6 million baht. These are the expenses covering the API cost, domain hosting, and the marketing, cloud computing. The total is gonna be around 600K. So subtracting the expense from the revenue, we'll be having the profits around 5.5 million baht. To summarize our application, we're using the multi-model AI system combining Clip and other FICE, Lava, AI integrated parts. We also use the zero-shot classification BERT to instantly identify user needs and hybrid retrieval RAG architecture with cross and encoder ranking. And we project around 6 million baht, which is scalable business model to gain within 1 year period. And this is the end of our presentation. And thank you so much for watching our videos about our food assistant chatbots.
Part where we do the search